Hello friends, in today's question, a thin disk of mass m and radius r has a mass per unit area sigma r is equal to kr square, where r is the distance from its center. Its moment of inertia about an axis going through its center of mass and perpendicular to plane is. So this is our disk having mass m, and we have to find out its moment of inertia about an axis which is going through center of mass. Okay, so let us say this is the axis and it is perpendicular going into the mass, so represented as x. So in this case we consider that there is a small disk of mass dm at a radius r from the center. Consider a small disk of mass dm having radius is equal to small r. So if I is the moment of inertia of this entire disk, so we can say moment of inertia of the thin disk, if it is given as I disk, then this I disk will be equal to integration of r square multiplied by dm. It means these small masses will be added and the limit of integration will be varying from 0 to capital R. Now in the question it is given that mass per unit area, mass per unit area, which is equal to sigma r is equal to kr square. Therefore we can say that our dm will be equal to sigma r into dA, where dA is the area of this small disk dm, and area of the disk is equal to pi r square. So from here we can find out that our dA will be equal to 2 pi r into dr. Therefore this dm can be written as, for the sake of convenience, let us remove this r, so we are going to simply write it sigma, and dA comes as 2 pi r into dr. So substituting the value of dm in the equation, we get I disk. Therefore moment of inertia of the disk with the limits 0 to r is equal to r square and multiply by dm. Dm is our sigma. This is 2 pi r into dr. This can be further solved as 0 to r. This comes as 2 pi sigma, and this is r cube dr. Now the sigma is also having a dependence upon r, okay, because it is given that sigma r is equal to our kr square. So sigma is not a basically constant, it is depending upon r. So substituting here kr square, we get 0 to r, this will be 2 pi k r square r cube dr. So this can be 2 pi k, we get r5 dr 0 to r. Now it's a simple integration. We get I disk will be equal to 2 pi k r6 upon 6 0 to r, so which will further as substituting the upper and lower limit, we get 2 pi k and r6. Now in the option we have the relationship only between m and r, so in this final answer we are going to substitute the value of k with the value of m. So we already know that our dm is, we found out that our dm is equal to sigma 2 pi r dr, substituting value of sigma, which is kr square. This is 2 pi r into dr, so we get dm as, therefore the dm will be equal to two pi k r cube dr, 2 pi k r cube dr. Therefore the total mass which is given as capital M will be equal to integration 0 to r for dm. Substituting the value of dm, we get 2 pi k, this is r cube, and dr, m is equal to 2 pi k is constant, we get r4 upon 4 0 to r, which gives us 2 pi k by 4, and this becomes r4. From here we can find out the relationship, or we can change it from k. So this implies that value of k is equal to, we get 4m divided by 2 pi r4. Therefore I disk is equal to, I disk was our 2 pi k r6, 2 pi k r6, substituting value of k, we get this as 2 pi r6, and become this as 4m divided by 2 pi r4. 2 pi cancels out, and this is r, sorry I missed out here, 6, this is 6, and yeah, here also I missed out, this is upon 6. So therefore, and this comes as 2 and this is 3, so we get I disk is equal to 2 by 3 m, this is r4, and this goes, and we remember this will be coming as r6 minus 4, so this will be r raised to power 2, r raised to power 2. So this is the moment of inertia of the disk. This is the moment of inertia of the disk having mass per unit area given as sigma r is equal to kr square. It means the option number D is the correct option. So we can say option D is correct option. Okay. So this completes the question. Thank you.